Hi students, now I'm going to explain the problems on BJT configurations. I'm Dr. B. Ravi Kumar, Associate Professor, Department of ECE, Institute of Aeronautical Engineering. So basically we have three configurations in BJT: common emitter configuration, common base configuration, and common collector configuration. So how to solve the problems, the simple problems in all these three configurations? Basically, these three configurations are the configuration of transistor put in a network to understand the behavior of the transistor. So in order to understand the behavior of the transistor, connected in a common base configuration and see that, and the common emitter configuration, observe that, and common collector configuration, see the behavior of the device. So these are all things I explained in theory. So let us see that when a particular transistor in common base or common emitter or common collector, then how to solve the problems. Basically, we know that when we see this configuration, the common emitter configuration, when transistor connected in common emitter configuration, so the output collector current basically IC is equal to beta IB plus ICE naught. There, this is called majority current. This is called minority current. This is total collector current, the current reached to the collector IC. When it comes to CP, this current becomes IC is equal to alpha IE and ICB naught. And the common collector configuration, IE is equal to gamma IC naught. Common collector IEC naught. And we know that basic fundamental formula in any transistor. Let us, this is a transistor. Take that this node is like a transistor, and emitter current comes here, and base current leaving here, and collector current leaving here. The total current total, we assume that the total emitter current IE is equal to, apply the KCL law. When we apply it, total current IE is equal to sum of IB plus IC. And also we have a parameters current gains in each configuration. CE configuration current gain, we can call it as beta is equal to IC by IB. And the common base configuration alpha IE by IC by IE. And the common collector configuration gamma is equal to IC by IE. Sorry, common collector IB, IC by. Sorry, emitter current common collector emitter collector output collector current base current. So IB IE by IB, IE by IB. These are the helpful formulas to find out these simple problems on transistor configurations. And also there are some relationship between alpha, beta, gamma, so which will be helpful for some problems to find out the relationship between alpha, beta, gamma. Some problems have given the details of alpha and then find out the beta, and some currents, there's some like emitter and base currents, and some and beta is given. We need to find out the alpha, so that this alpha beta relation helpful to find out those things. Alpha is equal to beta by 1 plus beta. Beta is like sorry, beta is equal to alpha by 1 minus alpha, and beta is equal to 1 plus gamma. You can also like gamma is equal to 1 by 1 minus alpha. All these relationships between alpha, beta, gamma, the current gains in common base, common emitter, common collector. Let us see this. Let us see to solve this problem based on these formulas. But let us read first and then note down that what are the requirement given parameters and what are the requirement parameters need to be find out, and then substitute those things in a formula. Then you will find out the required answer. A transistor like operating. One second. When a transistor operating in common base configuration has IC is equal to 2.98 milliampere, IE is equal to 3 milliampere, because when it is common base configuration, like when it is common base configuration, the base is common and the input is emitter current and output is collector current. That's why the given data is IC is equal to 2.98 and the input current I is equal to 3 milliampere, and IC naught. What does it mean? IC naught means in the common base, the current between collector to base when emitter terminal is open, input terminal is open, that then the current is 0.01 milliampere. What current will flow in the collector circuit of this transistor when connected in common emitter configuration? With those parameters, when we change that configuration from CB to CE with the base current of 30 milliampere or microampere, so what will be the current flow in the collector when it is connected in common emitter? Let us see now. Write down the first, take the given parameters. Given parameter, given data. It is a common base configuration. Common base, emitter is input current, collector is output current, this is base current. So the given data, collector current IC is equal to 2.98 milliampere, 2.98 milliampere. IE is equal to 3 milliampere. Then IC naught, where IC naught, what is the current flow between collector and base when emitter terminal is open? Emitter terminal is open. So collector to base current when emitter terminal is open, then that current is called 0.01 milliampere, which simply say that the output reverse bias junction current it is. And then what will be the IC current when it is connected in CE? If it is CB connection data. What if connected in CE configuration with IB is equal to 30 microampere. 30 microampere. Basically, so first the given data, we need just find out take that given data and then recollect that the collector current flow when it is connected to common base configuration. Common base configuration IC is equal to alpha IE plus IC B naught. And we have a alpha? No, we don't have alpha. And we have a IE? Yes, we have a IE. And then IC B naught, yes, IC B naught. So we need to find out, it is the from the given data we can take that alpha. Otherwise, actually, we just find out the that IC is given in the common base. So we need to find out the IC in a common emitter. What is the current flow in common emitter? Collector current IC is equal to beta IB plus IC naught. Collector to emitter when base is open. So do we have IB? We don't have IB. We need to find out IB. Do we have beta? No. We need to find out beta. It's required to find beta and IC naught. Everything we need to find out. So first we find the the given data beta. So what is that beta? Beta is equal to alpha by 1 minus alpha. So how to find out alpha from the given common base configuration data? So from this data we can find out alpha is equal to IC by IE, common base configuration current gain. Two data have given. So IC given 2.98 milliampere divided by 3 milliampere, which is equal to alpha, which is equal to alpha is equal to 2.98 by 3, approximately 0.994. Take that alpha and substitute it into beta. You will get the value of beta, which is always greater than the range between 100 to 200 to 50. So alpha range is always between 0.9 to 0.99. So 1 minus 0.994, you will get 0.994 divided by 0.006, which is approximately equal to 165. So what is beta now? Beta is 165. So beta is equal to 165. Then, so this is one parameter we find out. One parameter just now find out. Then remaining IB and IC naught we need to find. How can we find the IB? And it is given that IB 30 microampere in a common emitter configuration. So this one is given. This one is found already found. And IC naught. What is IC naught? Basically, IC naught is equal to 1 plus beta times of IC B naught, because when in a common base configuration, the reverse saturation current or reverse bias current flow between collector to base when emitter is open is very small, because most of the current flow coming from emitter when it was open, the only the microampere current flow in the common base configuration. But when we compare with this common emitter configuration, but with the input is open, that is called IC naught. So when base is open means collector to emitter current is somewhat large. So that how much large means we can relation between IC naught to ICB naught. 1 plus beta times of ICB naught flow in the common emitter configuration. So this is what we find out this in the second term in the formula. So IC naught is equal to 1 plus beta is equal to 165 into ICB naught. ICB naught is given in the problem. ICB naught 0.01 milliampere. 0.01 milliampere. 166 into 0.01 milliampere means we will take 1.66 milliampere. If you see these two parameters like 1.666 milliampere and 0.01 milliampere, that is the difference. Okay, always ICB naught is 10 and like 1 plus beta times of IC naught. And then now substitute common emitter configuration current, collector current IC is equal to beta IB plus IC naught. Beta already we found 165 into IB 0. IB my 30 microampere. 30 microampere plus IC naught 1.66 milliampere. So it will be converted that into 4.95 milliampere. It is 30 multiplied by 30 micro multiplied by 165. We'll get 4.95 milliampere plus 1.66 milliampere. So finally, you will get IC is equal to you will get 116 6.661 milliampere. This is collector current flow in the collector when the transistor connected in common emitter configuration. The current flow in the transistor common emitter configuration is 6.61 milliampere. Which current flow when it is in common base configuration? 2.98. But when it comes to common emitter, that collector current is become 6.61 milliampere. So simply the given data was that given in a common base configuration data and find out the common emitter configuration collector current. So immediately we take that formula for collector current in common emitter and check it out that which parameters need to be find out in the given equation, like in the equation. So based on that, we will collect all the formulas and relation between alpha and beta, and then all the IC and IB and IC naught formulas. Then substitute, you will get this from 6.61 milliampere. Let us see some other problem. In this problem, very simple, like transistor has emitter current. Transistor has emitter current. IE is equal to 10 milliampere. What about alpha? In the given problem, alpha is given 0.98. Alpha is always range less than or equal or approximately equal to 1. Determine the value of IC and IB. Determine the value of IC and IB. So what is there any relationship between IC and alpha and IE? Yes, there is the relation between. So let us see that one. So we know that the common base configuration current gain alpha is equal to common base configuration output current collector and input current IE. This is the relation. So we also we have this given data is alpha 0.98 and IC divided by IE is equal to 10 milliampere. So when we take this IC left side, then that 0.98 multiplied by 10 milliampere, so you will get 9.8 milliampere. So IC always large current, so 9.8 milliampere. Once we get an IC and we have already IE, the basic relationship terminal transistor Kirchhoff flow, like total current flow in the transistor is equal to base current leaving current plus collector leaving current. IE is equal to IC plus IB. So two data are known. take that 9.8 milliampere plus IB. Where is IB? Okay, I is given 10 milliampere. So we need to find out IB. IB is equal to 10 minus 9.8 milliampere. We'll get 0.2 milliampere or 200 microampere. In this way, we will find out the IB and IC. And some another problem. In this problem, determine the common base configuration collector current. Common base configuration collector current. Once again we take those formulas. IC formula. Collector current for a given parameter alpha 9.8, 0.99, IE 3 milliampere, IC B0 10 microampere. By seeing the parameters, is directly given that collector current. The given data. The given data, it is a common base configuration. In the common base configuration, alpha 0.98, IE 3 milliampere, IC B0 10 microampere. So when we take that formula, common base current, collector current IC is equal to, in the common base, IC is equal to alpha E plus IC B0. All are given, direct formula. So alpha is given 0.98. Into IE is equal to 3 milliampere. 3 milliampere plus IC B0 10 microampere. We'll take that 2.94 milliampere plus 0.01 milliampere. That micro converted to milli. Then total is 2.95 milliampere. This is the collector current we got in this given problem. This is the direct problem. All the parameters are given in common base configuration. Directly we will take the collector current in common base, then we will substitute it and then we will get the answer. So these problems will take from the question bank, IARE question bank, Analog and Digital Electronics, and also we can take that different books like electronic devices and circuits by R.S. Seda and Salivahana. So this R.S. Seda also given this kind of problems in the book. So you have to practice it. So this is about problems on transistor configurations. So you can take any problems by taking those formulas. Then you will find easily. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.